Welcome to The Explainer. Today, we are completely rethinking everything you know about artificial intelligence and bias. I mean, we constantly demand that our AI be perfectly 100% neutral, right? But what if scrubbing every single ounce of bias from AI is actually the very thing preventing it from achieving true intelligence? It's a massive paradox. We're going to unpack exactly why human cognitive bias isn't just some bug in the system. It's actually the primary feature that makes us smart. Let's get right into it.
Okay, let's dive into this. Think about how we've been taught to view cognitive bias in our everyday lives. We usually imagine it as this giant, annoying rock we keep tripping over. We treat it as an error, a frustrating stumbling block that just gets in the way of pure, rational logic. And because we view bias as a fundamental flaw in human reasoning, we naturally expect that our highly advanced machines should be completely free of it. We expect them to calculate without prejudice. But here's the thing. This assumption misses a massive foundational truth about how real biological intelligence actually operates out there in the wild. See, psychology has actually known for decades that human thinking is not purely rational, and honestly, that is by design. Back in 1972, pioneers Amos Tversky and Daniel Kahneman introduced the whole concept of cognitive biases. They showed that instead of evaluating every possible option logically, which, let's be real, would literally paralyze us with indecision, the human brain relies on heuristics. These are basically mental shortcuts, and they're shaped by our memory, our experience, and our attention. Cognitive bias is actually the engine of human intelligence. It takes those metaphorical stumbling blocks and turns them into vital stepping stones, allowing us to navigate an incredibly complex world quickly and efficiently.
Section 1. Why bias is a feature.
To truly understand how we need to build the AI of the future, we first need to look under the hood of our own biological neural networks. We have to understand why bias is fundamentally a feature, not a bug. When we talk about cognitive bias in behavioral science, what we're really talking about are subconscious shortcuts. And these are driven by four core principles of the brain's neural network: association, compatibility, retainment, and focus. So, for instance, your brain uses association to form super quick correlations just to survive, right? And it uses compatibility to prioritize information that aligns with what you already know. Now, yeah, while these principles absolutely cause cognitive illusions, like overestimating patterns or falling hard for confirmation bias, they are absolutely essential. Without them, you literally wouldn't be able to learn, adapt, or make any intuitive leaps.
Section 2. The AI feedback loop.
Now here is where things get really interesting and, honestly, a little bit dangerous. What exactly happens when our beautifully biased, shortcut-driven human brains start interacting every single day with modern machine learning? Well, we get a major structural mismatch. Standard large language models, the chat systems you and I use today, are essentially stateless inference engines. They load up your context, generate a response, and then boom, they terminate. They reset every single session. Human cognition, on the other hand, evolves its behavior through accumulated experience. We go from experience to memory bias to heuristic weighting and finally to a decision. We build upon our past. So, when a stateless machine interacts with a highly stateful, biased human, the machine literally just reflects and amplifies whatever the human brings to the table in that specific moment. So the crucial point is this: it creates a bidirectional feedback loop with some seriously dangerous operational risks. When we interact with AI, we naturally default to our System 1 thinking, those fast, intuitive heuristics. We engage in cognitive offloading, basically letting the AI do the heavy mental lifting, which, spoiler alert, leads to skill erosion. And because engagement-driven algorithms are designed to exploit our vulnerabilities to give us exactly what we want to hear, this loop rapidly amplifies polarized echo chambers. The AI reinforces our pre-existing biases, and we, in turn, train ourselves to trust the AI only when it agrees with us. It's a vicious cycle.
Section 3. Collapse-aware AI architecture. Clearly, trying to build stateless, perfectly neutral AI just isn't working when it's paired with humans. Behavioral and computer scientists are now realizing we need an entirely new structural design to bridge this gap. Enter Collapse-Aware AI, or CAI. This is a genuinely revolutionary architectural direction. Instead of treating bias like this catastrophic error that has to be eliminated, CAI models bias explicitly right within the system's decision-making dynamics. Using something called the Simonu mathematical framework, it actually treats cognitive biases as structured variables. It essentially acknowledges that intelligence in real systems relies on bias, and it uses that very fact to stabilize the collaboration between human and machine. Let's look at how this actually flows in practice. Past interaction events create what are called weighted moments.
Those moments then lead to bias injection, which influences future probabilities. But here is the real magic. Step 3 is governor stabilization. Think of it like a massive safety lever on a runaway train. This architectural layer detects and prevents runaway feedback loops before they spiral into extreme positions or cause total behavioral collapse. It doesn't erase the human bias, it actively manages it to keep the human AI teamwork completely stable and productive.
Section 4. The human side of prompting. Now, while engineers are off building collapse-aware AI, we also have to take a hard look in the mirror. Because right now, the way we personally use AI is fundamentally skewing the results we get. And this brilliantly illustrates a framework developed by researchers Cheng and Grant about how bias infiltrates every single stage of AI interaction. Think about it. Before you even type a prompt, the halo or horns effect shapes whether you trust the AI way too much or way too little. During prompting, we constantly use leading questions, like asking, "Why is this product the best?" which totally forces the AI to ignore any weaknesses. And then after prompting, confirmation bias kicks right in. We eagerly accept the AI's output if it matches what we already believe, and we completely reject it if it challenges us. I actually want to pause here and ask you to think about your own daily habits with AI. I mean, how often do you just blast a question into a chatbot purely to confirm something you already suspect is true? We so often think of AI as this ultimate tool for speed. But to overcome our own cognitive biases, we actually need to use AI to slow down. We need to actively ask the AI to point out our logical gaps, to surface our hidden assumptions, and to provide diverse perspectives that we hadn't even considered. True AI integration isn't just about the speed of the output. It is entirely about the quality of the thought.
Section 5, debiasing and choice architecture.
So, what does this all mean for the big picture? How do we fix this on a larger scale? When you have entire teams or organizations using AI, you can't just cross your fingers and hope everyone will magically stop being biased. Researchers have developed a super powerful dual framework to mitigate these cognitive risks. On one side, you have debiasing. This is active training to help decision makers recognize and counter their own biases. It's absolutely great for complex, high-uncertainty decisions. On the other side, you have choice architecture. Now, this doesn't try to change how people think, it actually changes the environment they make decisions in, like altering default options in a software interface. It's incredibly effective for routine decisions and for reducing overall cognitive load. To build a truly complete solution, the magic number here is 2. Organizations absolutely must use a two-pronged approach. You literally cannot rely on just one. You need debiasing workshops to build up human critical thinking, and you need choice architecture built right into your software environments to catch all those routine biases. Combining human-centric training with smart system architecture is, for sure, the only way to break those systemic bias loops we've been talking about. Which brings us to the ultimate question. We've seen today that cognitive bias isn't a bug. It's the very shortcut system that allows biological brains to function in reality. So if bias is actually the engine of true intelligence, what exactly are we trying to build here? Are we designing AI to actually think, adapt, and collaborate with us in the messy real world? Or are we just building incredibly fast calculators that will inevitably break down the second they encounter human nature? It's a profound challenge for the next generation of tech, and one that absolutely changes exactly how we should be interacting with these tools today. Thanks for joining me on this explainer, and I really hope this leaves you with some fascinating ideas to chew on.